bracket, that's what's going to end up getting you. So it's really important that you guys are careful when you do this. So domain are all the X's. Remember that from yesterday. So here's different situations that you could have to find the domain. So if you just have a set of numbers, you're looking at the X's. And then you just say from the least to the greatest number. Now, since these are actual numbers that are included in the domain, we have like specific, we don't have a range of numbers with every number in between. We're just going to do like curly brackets and then write them in, just like a plain set of numbers. So domain, curly bracket, and we're going to say they don't have to be in order. I usually just do the order that they're presented. It's whatever you want to do. We don't duplicate, so I won't write another 8. And that's just it. Range are all the Y numbers, all the Y values, up and down, if it was a graph. So we are looking at these. Make sure there's no duplicates. There isn't, so we're writing them all. So if you have a set of numbers, you're going to just list them out. Mapping, same way. You just have a few specific numbers. You don't have a whole range of values. So same process here. No duplicate, so I'm just writing them. All right, so if you were to graph these, you just have a graph full of various points. But on this one, this is a continuous function. You can tell by the arrows, it just keeps going in all directions, like left and right and down, forever and ever and ever. So we can't just do a set of numbers because we'd be writing numbers forever. So because this is a continuous function, we have to present the domain and range in a different way. So this is where the notation comes in, whether or not they're brackets or parentheses. So the domain here, when you're looking at the X's, even though this looks like it's going down, it doesn't stay at this -4. It keeps going in both of these directions. So it goes from -infinity to +infinity. So domain, depending on what is asked for. A lot of times it can be really generic and you can just put this weird looking R, which means all real numbers. You can say all real numbers, but interval notation, which is usually what they want, you would write with parentheses like this. It's important that you write parentheses because it means that you don't include the infinities, because you can't include infinity. It's not an actual number. The range, however, does have a stopping point or a starting point, however you want to look at it. It doesn't go any higher than this 2, but it does go low forever and ever. So the range here would go from bracket 2, comma, infinity with a parenthesis. The bracket means that, or sorry, negative infinity. Let me flip that around. The bracket means that it includes that number 2. Like it is on number 2. At 2, there's a value for X. So parenthesis non-included, bracket included. All right, and then D is similar to A and B, except for it's actually plotted on a coordinate plane. So you have to figure out what those ordered pairs are. So you're going to look at, you can either write down what each of the points are and do it that way, or you can just try and not mess up when you look. So I see a 1, I see a -2, I see a -3, I see another -2, but I don't have to include that, and I see another 1, I don't have to include that. Range would be the corresponding y values. So I see a 1, a 0, a -1, a -2, and a -3. And just for fun, this is not a function because it has two of the same x values, but they are in different y positions. So not a function, as a review for yesterday, is a function. We did the vertical line test. There's no duplicate y's for the same x's. This one, not a function because there's 2 8s and they go to different y's. And this one, all these are coming off and pointing to, there's only like one coming off of each x, so that would be a function. All right, the next page. All right, so this, you're going to find the domain of all the functions. You're going to graph them. You can use a graphing calculator to graph them if you need. So these ones are going to have some excluded values. Okay, you're going to have excluded values if you have if you plug in an x number and you end up with a 0 in the denominator. Okay, or if you end up with an even root with a negative number inside. So if you plug in any x value into your equation that results in a 0 in the denominator or a negative number underneath the even root, then you have to exclude those values from your domain. All right, so for this one, we're going to put it in y equals form. It makes it easier to see if there's any values that you have to exclude. So since we have a square root here, there is going to be a number that if we plugged in here, that we would end up getting a negative value. We can have 0. 0 is okay. But if we end up in a negative because this is an even root, then that's a problem. So this is plus and minus. Okay, so what number? Basically, this whole thing under here has to be greater than or equal to 0. Okay, so you can set it up that way, or you could just figure it out in your head. Like if I plug the 3 into this x, then I would have 3 squared, which is 9. Then I would have a 0. That's okay. But if I plug anything between -3 and 3 in there, like not counting those two, then I'm going to have a problem. So if I plug -2 in here, I'm going to have a negative number under here. So that's going to give me an error. I have a -1 or any decimal in between. Do you follow what I'm saying? So you can also say this expression has to be greater than or equal to 0. In order for that to happen, x has to be greater than or equal to plus or minus 3. Do not forget the plus or minus. That's important. So this is where we have to do our excluded values. Now you can use inequality symbols, but you'll see more of the interval notation. So greater than or equal to positive 3 is going to be bracket, because we can include 3. And then greater than 3, there's no stopping, so we can just say infinity. So like this should be greater than or equal to positive 3 or less than or equal to negative 3. Does that make sense? Yeah, because negative 4, if we plugged in a negative 4, that would give us a positive 16. But if we plugged in a negative 2, yeah, we want to make this. I think it's because of this negative. Because if you plug in a negative 2, which is bigger than negative 3, it's going to result in a negative under there. So then we got this one accounted for. So we need to account for this one right here. So this is going to go backwards from negative infinity all the way to that negative 3 value. So we can't have a bracket on negative infinity because it's not an actual number. And then we can go to negative 3 because that would result in a 0 under the square root, and that's okay. So that's interval notation. You could also, if you did it as a compound inequality, you could say like that. But generally speaking, you'll see it with the brackets and the parentheses. Does this ask for range? No, it only asks for domain. As far as graphing goes, you guys can use a graphing calculator, but here's your asymptotes. So there's your asymptotes, and this isn't going to be perfect by any means, but. This will help you visualize what's happening. As far as the x values go, you can see that there's no x values for the graph in between negative 3 and 3. They start at 3 and go up, and they go to negative 3 and go down. All right, the next one's a quadratic. You guys could probably graph that without a graphing calculator. So you can figure out the vertex. I'm going to just do it for extra practice. You plug that in, you end up with the negative 2 for the x, then plug negative 2 in. So your vertex is at -2, -4. And then you have to get this in factored form anyway, so to make it graph easier. So to figure out the x-intercepts, you set each factor equal to 0. That'll give us 2 other points that we can use to graph. So it crosses here and here. It's a quadratic graph, so right away, if you looked at it and you notice, since it's quadratic, it's going to go left and right forever. So this is going to be all real numbers or negative infinity to infinity. All right, the next one, this one will have some restrictions because we have a denominator. So the first thing you want to do when you see this is you want to factor the bottom. So this is a sum difference, so this will be x plus 2, x minus 2. So that results in 2 restricted x values. X can't be -2, and it can't be +2, because if we plug either of those in there, we get a 0 in the denominator. All right, so because this is a whole other lesson that we get to, and you guys might have done it in algebra too. These are going to be asymptotes. So there's going to be an asymptote here and here, because x can't be those. And then if you put this in your graphing calculator, it's going to look something similar to this. Definitely not exact as far as where it's crossing, but we're just using this as a reference for our domain numbers. So this, we're going to state this as far as x goes. So negative infinity to -2. -2 is not included. And then we jump over -2 and we start back right next to -2. And then we go to +2. Neither of those are included. No, because -2 is not included. Like every number up, every decimal, minute little bit up until -2, and after -2 is included, but -2 itself is off limits. And then same thing here. It picks up on the right-hand side of 2 to infinity. So -2 and 2 are off limits, so that in interval notation would be how you state it. All right, this one, if you graph it in your calculator, it's going to look something along the lines of something like this. So again, we have square root. We can't have 0 in the denominator or in anything less than 0 under the square root sign. So this expression has to be greater than or equal to 0, so we don't get an error. Solve for the x values. Which looks about what our graph says. Except for I forgot to change my sign when I divided by a negative. That's better. Maybe I should change it here. I divided by -4, so we got to change the sign. Matt, you have a question?
No, it's just how we did it now.
Okay. All right, so don't do what I did. So now if you look at the graph, it looks like it's right up by 1, which is approximately 3/4. It goes in the negative direction, so all those values are okay. Any value to the right of the 3/4 is not okay, because those values would result in a 0 or a negative number under the square root sign. So domain. If we were saying it as an inequality, that's exactly what we'd write. X is less than or equal to 3/4. Because we're doing it in interval notation, we have to use the parentheses. So it goes from -infinity to 3/4. We can include 3/4 because that would result in a 0, square root of 0, which is okay. Like on an SAT test, they will specify, explain the domain using inequalities or by using interval notation. So then you would have to adjust your answer for whatever they ask for. And then we have 2 application problems, which are pretty simple. All right, so we have Terry, who works at an electronics store. She earns $275 base pay. So that's going to be like that plus number at the end, plus $15 for each item sold. So it's like commission, I guess. Express her gross salary G as a function of the number X. So it looks like we're doing like a G of X thing and not F of X. Find her gross pay if she sells 12 items. So this is a 2-part problem. Express the equation. So it says use G of X as her gross pay expression. X is the number of items sold. She gets $15 per item sold plus that extra $275 base pay if she doesn't sell anything. You don't need the dollar signs. You can keep them or you cannot. So there's the first part. Second part is how much money did she make if she sold 12 items. So plug 12 in for X, just like the problems we did yesterday. Plug it in, and she makes $455. All right, last one. If your pre-calc book, if you had a pre-calc book, is dropped from a height of 25 meters on the planet Newton, is its height in meters after t seconds is described by that equation. How long did it take the book to hit the surface of the planet? So basically it's asking you when h of t is 0. The surface of the planet would be 0. So this would be h of t equal to 0. All right, so we have this equation. They already gave it to us. We know that I'm looking for when h of t is equal to 0, so I'm going to plug that in the next line. Make that equal to 0 and solve for t. Oh, what's that? 20. Oh, we'll just leave it as 20. You can get the decimal if you want, but I don't know what that decimal is, so I'm just going to leave it like that. If you plug all that into your calculator, you should get about 1.443 seconds. So it's going to hit the surface of the planet in about 1.443 seconds. Okay. Is that right? All right, so that is the remainder of our 1-1 notes. Questions online? Caleb, yeah, all the documents are in Google Classroom. Try just opening the PDF version. Oh, I don't know why it looks weird. All right, so one more time, you guys, especially for anyone that came in later before I mention it. So remember that 15 through 24 in your homework did not get copied. It's online, but if you have the packet, you're going to be missing those. So you're going to have to look online and write them on paper. When you guys are done, you're going to take screenshots of all the work. Now, this is what I am like demanding, or you guys are going to redo it. You cannot use scratch paper and randomly put problems all over the place. Like you have to order them in numberly fashion, 1, 2, 3, 4, where I can see, not stuff everywhere. Okay. So make sure that you, if you're writing this stuff, especially for those problems, 15 through 24, that you number them. screenshot all your stuff, put them in the Google slide that I've attached to this assignment in Google Classroom. Got all that? Yeah. Understand? As far as it opening weird, I don't know. Can you guys open it? Looks okay?
Yeah, fine.
Caleb, I don't know what that issue is. All right. All right, so I'm gonna put myself on mute, but I'll do that whole help room thing again. So if you want to ask questions, you can go in there and then you're not broadcasting it to the whole online group.